Hello everyone, welcome to Infinity Learn. My name is Vibhati and I'm your physics educator on Infinity Learn. So let's start today's discussion of MPL physics paper weekend test 12. So let's start with question number 1. The ratio of accelerations for a solid sphere, mass m and radius r, rolling down an incline of angle theta without slipping, and slipping down the incline without rolling is. So in the first case, acceleration is for the rolling body. That means it is g sine theta upon 1 plus k square upon r square, right? For solid sphere, moment of inertia is 2 by 5 mr square, and this is equals to mk square. So k square upon r square for solid sphere is equals to 2 by 5. So moment of inertia is 2 by 5 mr square, which is mk square, and because of that k square upon r square is 2 by 5. So acceleration of the rolling body in this case will be g sine theta upon 1 plus 2 by 5, which is 5 upon 7 g sine theta. Similarly, acceleration of a body which is sliding, right? So acceleration of the sliding body is g sine theta. Now the ratio of a rolling divided by a sliding will be a rolling divided by a sliding will be 5 by 7 g sine theta divided by g sine theta. So it will be 5 is to 7, which is option 1. Question number 2. Three identical spherical shells, each of mass m and radius r, are placed as shown in figure. Consider an axis xx dash which is touching to two shells and passing through diameter of the third shell. Moment of inertia of the system consisting of these three spherical shells about xx dash axis is. So for the first upper one, let's number this 1, 2 and 3. So for the first shell, the moment of inertia will be about its geometrical axis, right? Will be about its diameter. So this is spherical shell. So moment of inertia for hollow sphere or a spherical shell is what? I1 is 2 by 3 m r square. For the second and third shell, moment of inertia is passing through the tangent. The axis of rotation is passing through the tangent. So we need to find the moment of inertia about this axis. This is equal to r. The separation is equal to r. So this is nothing but the application of parallel axis theorem. So if this is I1 and this is ICM, then you can write I1 is equals to ICM plus MD square. है ना? D is the separation between these two parallel axes. ICM is what? Moment of inertia passing through the center of mass. So for this case, it is 2 by 3 mr square. So ICM will be 2 by 3 mr square plus mr square because D is equals to r. So it will be 5 by 3 mr square. Similarly, for the third shell, again, moment of inertia is about the tangent. So again, for the third shell, this will be, let's say this is I2, then I3 will be 5 by 3 mr square. So total moment of inertia of this configuration is I1 plus I2 plus I3, which is 2 by 3 mr square plus 5 by 3 mr square plus 5 by 3 mr square. Fine, so it will be 12 by 3 mr square, which is equals to 4 mr square. Option 2. Question number 3. A particle of mass 5 kg is moving with uniform speed 3 root 2 centimeter per second in the xy plane along the line y is equals to x plus 4. The magnitude of its angular momentum about the origin in gm centimeter square per second is. So let's draw this straight line in the xy plane, right? So when you put the value of y is equals to 0, x plus 4 will be 0 and x is equals to minus 4. So this straight line is crossing x-axis at minus 4. Similarly, when you put the value of x is equals to 0, y will be 4. So the straight line is crossing y-axis at plus 4. So this is your straight line which is passing through these 2 points, minus 4 comma 0 and 0 comma 4. Fine. So this is your right angle triangle. So this side is 4, this side is 4. Okay, so this is isosceles right angle triangle, right? So this angle is 45 degree. This angle is also 45 degree. Now the particle is moving along this line with some velocity v, right? And we need to find angular momentum of this particle about the origin. So angular momentum about any point of a given particle is mv into r perpendicular. Mass is given, v is given. We need to find the perpendicular distance of the point from the line of motion, right? So this will be the perpendicular distance. This is 90 degree. So this angle is again 45 degree, right? So this, in this right angle triangle, this O, P, Q, in right angle triangle OPQ, base, if this angle is 45 degree, then base is unknown x, which is equals to r perpendicular. So r perpendicular base divided by hypotenuse, which is 4, is equals to cos 45 degree, which is 1 by root 2. So r perpendicular will be 4 upon root 2, which is equals to 2 root 2. So in this case, m is 5, v is 3 root 2 and r perpendicular is 2 root 2. So it will be 60. So correct answer is option 4. Question number 4. The kinetic energy of an object rotating about a fixed axis with angular momentum L is equals to I omega can be written as. So, omega is L upon I from this relation. Kinetic energy of rotation is given as half I omega squared. Just replace the value of omega as L upon I. So it will be half I L square upon I square and it is L square upon 2I. So kinetic energy in terms of angular momentum and moment of inertia is L square upon 2I, which is option 1. Next question is question number 5. A particle is moving in a circular path if its kinetic energy is doubled, keeping its angular momentum unchanged. The new angular velocity of rotation is. So let's assume that initial moment of inertia is I and initial angular velocity is omega, and final angular velocity is omega dash and final moment of inertia is I dash. Now according to conservation of angular momentum, I omega is equals to I dash omega dash. Kinetic energy initial is k, which is L square upon 2I, right? So L square is constant, L is constant. That means if this new kinetic energy 2k, then it will be L square upon 2I dash. We are not changing the value of L. So I dash will change. I will change to I dash. So from this relation, you can write k as L square upon 2I. So it is 2. L square upon 2I is equals to L square upon 2I dash. So this two terms will cancel each other. So we'll have I dash is equals to I by 2. Now put the value of I dash in this relation. So I omega is equals to I by 2 omega dash. So in this case, omega dash will be 2 omega, which is option 2. Question number 6. The position of a particle is given by r vector is equals to I cap plus 2j cap minus k cap and linear momentum by p vector as 3I cap plus 4j cap minus 2k cap. The angular momentum is perpendicular to. So L vector is r cross p vector. So it will be I, j, k, positive, negative, positive. For r vector it will be 1 plus 2 minus 1 and for p vector it is 3, 4 minus 2. So r cross p will be L vector, which is plus I cap of minus 4 plus minus 4. So it will be minus 4, which is plus 4, minus j cap, it is minus 2, minus of minus 3 and plus k cap, which is 4 minus 6, right? So it is 0, and it will be minus j cap plus 1 minus 2 plus 3 and plus minus 2k cap. So this will be 0 minus j cap 0 I cap minus j cap minus 2k cap. So this is L vector, right? Now we need to find the angular momentum is perpendicular to what axis. So let's consider unit vector along x-axis first, I cap, right? Let's take dot product of L vector with I cap. So it will be I cap dot 0 I cap minus j cap minus 2k cap. So it is 0 minus 0 minus 0, which is equals to 0. And if dot product of any two vector is 0, that means these two vectors are perpendicular to each other. So correct answer is option 1, right? Next is question number 7. The moment of inertia of a body is independent of mass of the body. It depends on the mass of the body. Yes. Distribution of mass of the body. Yes, it depends on the distribution of mass of the body. Next is temperature of the body. Yes, because on increasing or decreasing the temperature, there will be expansion in the body, and because of that, the distribution will change. So yes, this is also true. Next is angular velocity of the body. So it does not depend on the angular velocity of the body. So correct answer is option 4. Question number 8. In pure rolling motion of a ring, it rotates about instantaneous point of contact of ring and ground. Okay. Its center of mass moves in translatory motion only. And C part is its center of mass will have translatory as well as rotatory motion. So in pure rolling motion, the point of contact, the relative velocity of point of contact is 0. So it just rotates about the ground, right? So first statement is true. In next statement, velocity of center of mass is vcm and it performs only translatory motion. So this is also true. Okay, center of mass does not perform translatory as well as rotatory motion. So this is not true. So correct answer is option 3. Only A and B are true. Question number 9. A ring and a disc of same mass roll without slipping along a horizontal surface with same velocity. If the kinetic energy of the ring is 8 joule, then that of the disc is. So, basically, we have a ring of mass m and we have another object disc of mass m. So, this is ring, this is disc. Okay. Moment of inertia of the ring is mr square and moment of inertia of the disc is mr square by 2. Fine. Kinetic energy of the object which is performing rolling motion is given as half mv square into 1 plus k square upon r square. So k square upon r square for ring will be if you equate it to mk square, so for ring k square upon r square is equals to 1, right? So kinetic energy of ring is half mv square into 1 plus 1, which is mv square, and the kinetic energy of the ring is given as 8 joules. So basically mv square is equals to 8 joules, right? Now in the next statement we have disk, right? So disk, if you equate it to mk square, so k square upon r square will be 1 by 2. So kinetic energy of the disk kd will be half mv square into 1 plus 1 by 2, which is 3 by 4 mv square. Fine. But the value of mv square is 8 joule. So it will be 3 by 4 into 8, which is equals to 6 joule. So kinetic energy of disk is 6 joule, which is option 3. Question number 10. A cubical block of side L rests on a rough horizontal surface with coefficient of friction mu. The horizontal force F is applied over here on the block as shown in the figure such that the block is not sliding. Block is not sliding. The minimum force required to topple the block is. So when the block will topple, it will topple about point P. So normal will pass through this point P over here, right? Now this is mg. So the block will rotate about point P. So torque about point P should be greater than equal to 0, right? Greater than 0. It should be more than 0, slightly more than 0, so that the block can topple. So let's calculate the torque about point P. So this distance is L by 2 and this distance is L. So torque produced by F is FL and torque produced by mg is mgl by 2. Okay. And torque produced by F should be more than torque produced by mgl by 2. If you look at the torque produced by F, it will be in what sense? It will be into the plane, or it will try to topple this block in clockwise direction, right? Uh, on the other hand, if you look at the torque produced by mg r cross F, it will try to rotate this block about point P in anti-clockwise sense. So these two directions are opposite. Okay. So basically torque produced by F should be greater than equal to torque produced by mg. So F should be greater than equal to mg by 2, right? So minimum force should be mg so that this block can topple. So correct answer is option 3. Question number 11. 484 joules of energy is spent in increasing the speed of a wheel from 60 rpm to 360 rpm. The moment of inertia of the wheel is. So basically this is change in kinetic energy of the body, rotational kinetic energy. So kinetic energy initial is half I omega initial square. Omega initial will be what? This is revolutions per minute. So revolutions per second will be revolutions per minute divided by 60. So this will be frequency of rotations, and for the first case it is 60 by 60, which is equals to 1 revolution per second. So omega is 2 pi f. So first omega will be 2 pi into 1. So this is 2 pi radian per second. Second omega final will be 2 pi into second frequency of revolution, which is 360 divided by 60. So it is 6. So it is omega final is 12 pi radian per second, right? So K final will be half I omega final square. Change in energy is K final minus K initial. So it is half I omega final square minus omega initial square. So it will be half I 12 pi square minus 2 pi square, and this is equals to 484. So when you solve this equation, you'll get the moment of inertia as option 3.7 kilogram meter square. Question number 12. Two wheels of moment of inertia 3 kilogram meter square and 5 kilogram meter square are rotating at the rate of 600 rpm and 800 rpm respectively in the same direction. If the two are coupled so as to rotate with the same axis of rotation, the resultant speed of rotation will be in RPM. So basically we have two wheels and these two wheels are coupled in such a way that they are rotating about the same axis. So in this situation, net torque about the axis of rotation is 0. That is why you can conserve the angular momentum of this setup about the axis of rotation, right? So initial angular momentum of this complete will be 3 into 600. Angular momentum is I into omega plus 5 into 800, and now these two are rotating with the common angular velocity omega. Then it is final moment of inertia, that is 3 plus 5 8 into omega. So this will be 1800. 5800 divide is equals to 8 omega. So omega will be 5800 divided by 8 and it is 725. Question number 13. A satellite takes 1 by 8 years to move round the earth in its permissible orbit of radius r. So in the first case, r1 is given as r and t1 time period is 1 by 8 years. The period when it revolves around the earth in an orbit of radius 2r. So r2 is 2r and we need to find the value of t2. So you can apply Kepler's third law for solving this question. T1 square upon T2 square is equals to R1 cube upon R2 cube. So you can write T2 square as T1 square into R2 upon R1 cube, right? So T2 will be T1 into R2 upon R1 power 3 by 2, right? So T2 will be T1, which is 1 by 8 into R2, which is 2R divided by R1 is R power 3 by 2, right? So this is 2 power 3 into 2 power 1 by 2. So it is 1 by 8 into 2 power 3 is 8. Square root will be square root of 8. So it is 1 upon 8 into 2 root 2, which is 1 upon 4 root 2 upon 4, and that is 1 upon 2 root 2 years, right? So correct answer is option 1. Question number 14. A planet revolves round the sun in an elliptical orbit of minor and major axis x and y respectively. Then the time period of revolution is proportional to. So t square is directly proportional to cube of semi-major axis, right? Over here, the major axis is y. So t square will be directly proportional to y cube, and t is directly proportional to y to the power 3 by 2. So correct answer is option 4. Question number 15. Find the false statement. False statement out of this 4 statements. First statement is gravitational force acts along the line joining two interacting particles. Yes, gravitational force acts along the line joining these two interacting particles. So this is true. Gravitational force is independent of the medium. True. Gravitational force forms action and reaction pair. True. Gravitational force does not obey principle of superposition. Gravitational force do obey principle of superposition for more than two particle system. The net force acting on a single particle due to presence of all the particle is the vector summation of all the individual forces, right? So that is your principle of superposition. So wrong statement is option 4. Question number 16. The time period of a particle performing linear SHM is 12 seconds. So time period is 12 seconds. What is the time taken by it to make a displacement equal to half its amplitude from equilibrium position, right? So this is question number 16. Based on SHM, we need to find the time taken by this particle to make a displacement equal to half its amplitude from the mean position, right? So you can assume that the amplitude is A and equation of SHM is x is equals to A sine omega t. Now displacement x is given as A by 2. So A by 2 will be A into sine omega t. That means sine omega t should be 1 by 2. Sine is 1 by 2 when the angle is pi by 6 or 30 degree. That means omega t should be pi by 6. Omega can be written as 2 pi divided by time period into t is equals to pi by 6. So t will be pi upon 6 into 2 pi into capital T. Capital T is time period, which is 12 seconds. So this will be pi upon 12 pi into 12, and it will be 1 second. So time taken by this particle to complete a displacement equal to half of its amplitude from the mean position is 1 second. Question number 17. The period of a simple pendulum measured inside a stationary lift is t. If the lift starts moving upwards with an acceleration g by 3, then what will be the time period? So time period of a simple pendulum is given as 2 pi under root L upon g effective, right? So when you look at this bob of the pendulum from the lift, okay, from non-inertial frame of reference, so it will experience tension in upward direction, mg in downward direction, and since lift is moving upwards with an acceleration g by 3, right? So it will experience one more force, pseudo force mg by 3 in the downward direction according to the observer, which is inside the lift. So total downward force is mg plus mg by 3, and this will act as total apparent gravitational force according to this observer. So you can write it as mg effective. So G effective in this case will be, mg effective will be 4 mg by 3, or G effective will be 4 G by 3, right? So time period will be, in this case it is 2 pi under root L upon 4G by 3, and that is equal to 3 under root 3 by 2 into 2 pi under root L upon G. Okay, so time period T is 2 pi under root L upon G when this lift is stationary, right? So it can be written as root 3 by 2 into capital T. So correct answer is option 4. Sorry, option 4. Next is question number 18. A uniform circular disc of mass 12 kilogram is held by two identical springs. So you can assume that the spring constant is Kk as shown in the figure. When the disc is pressed down slightly and released, it executes SHM with a time period as 2 seconds. The force constant of each spring is. So now these two springs are in parallel combination, right? So K effective will be 2K. Time period of spring block system is 2 pi under root m upon k, right? So over here 2 second is equals to 2 pi under root m. M is 12 kilogram and k effective is 2k. So if you square this value, you will get 1 upon pi square is equals to 12 upon 2k. So k will be 12 pi square divided by 2, and this is 6 pi square, right? So it is approximately 60. So nearest option is option 3, 59.15 Newton per meter. Question number 19. Two rings of same radius and mass are placed such that their centers are at a common point and their planes are perpendicular to each other. So this is ring 1. This is the center, and we have another ring, and this ring is in the different plane. Okay. So one is like this and one is like this. Fine. Center is common, mass is same, and radius is r. The moment of inertia of the system about an axis passing through the center and perpendicular to the plane of one of the ring is. So for this red ring, this is the axis. Okay, so this is the standard axis passing through the center of mass and perpendicular to the plane of the ring, right? So moment of inertia of this ring about this axis is mr square. But for the black ring, the axis is passing through the plane, in the plane of the ring and through the center of mass of the ring, right? So in this case, moment of inertia is given as mr square by 2. So total moment of inertia of the system is I1 plus I2, which is mr square plus mr square by 2, and this is 3 by 2 mr square, which is option 3. Question number 20. An ice skater starts a spin with her arms stretched out to the sides. She balances on the tip of one skate to turn without friction. She then pulls her arms in so that her moment of inertia decreases by a factor of 2. In the process of her doing so, what happens to her kinetic energy? So in this process, entire angular momentum is constant. So kinetic energy is L square upon 2I. If L is constant, that means I is changing. Okay, fine. In order to change the kinetic energy, I will change because of the change in distribution of mass about the axis of rotation. I will change, right? So it is L square upon 2. I is K dash will be L square upon 2I dash, right? I dash is the new moment of inertia, which is I by 2. It is given in the question. It decreases by a factor of 2. So L square upon 2, I dash is I by 2, and this will be 2 times L square upon 2I, right? So L square upon 2I is the original kinetic energy. So K dash will be 2 times K. Fine. So kinetic energy increases by a factor of 2, which is option 2. Question number 21. three masses 700 gram, 500 gram and 400 gram are suspended at the end of the spring and they are in equilibrium. When the 700 gram mass is removed, the system oscillates with a period of 3 seconds. When the 500 gram mass is also removed, it will oscillate with a period of. Okay. So basically, when you are removing 700 gram mass, only these two masses are left, which is 500 and 400. So net mass is now 500 plus 400, 900, and the, let's say, the spring constant of the spring is k. So time period in this case is 3 seconds, which is equals to 2 pi under root m, which is 900 divided by k. In the next case, if you remove 500 also, remaining mass is 400. So time period is t, which is equals to 2 pi under root 400 divided by k. So let's divide this two equations. So we'll get 3 upon t is equals to 2 pi cancel. Under root k will cancel under root k. So we have under root 900 divided by under root 400, which is 30 divided by 20, right? So time period will be 2 seconds. Next new time period will be 2 seconds, which is option 2. Question number 22. If the mass of one particle is increased by 50% and the mass of another particle is decreased by 50%, the force between them. Let's say one particle is of mass m1, another particle of mass m2 and separation is r. So force of attraction will be G m1 m2 upon r square. Now you are increasing one particle by 50%. So new mass of m1 will be m1 plus m1 by 2, and you are decreasing another mass by 50%. So new mass of particle 2 will be m2 minus m2 by 2, and the separation is r. So new masses will be 3m1 by 2 and m2 by 2. So new force F dash will be G into 3m1 by 2 into m2 by 2 divided by r square, which is equals to 3 by 4 G m1 m2 divided by r square. But G m1 m2 divided by r square is the old force. So F dash will be 3 by 4 F. Now percentage change in F will be new force minus old force divided by old force into 100. So it will be minus 1 by 4 into 100, which is minus 25%. So if you look at it, it is negative. That means the force is decreasing by 25%. Next is question number 23. Two lead spheres of same radius are in contact with each other. So we have two lead spheres of same radius r and r are in contact with each other. So if material is same, density will be same. So mass can be written as density into volume, which is density into 4 by 3 pi r cube. Now we have two identical spheres, right? So mass of these two spheres will be same. Separation between their centers, capital R, is given as 2r. Okay. Now if two lead spheres of double the previous radius are in contact with each other, the gravitational force of attraction between them will be. So in this case, let's find gravitational force of attraction. F is equals to G m1 m2, which is 4 by 3 rho pi r cube whole square divided by 2r whole square. So it will be G 4g by 9 rho square pi square 4g by 9 rho square pi square r to the power 4. Okay, so force is directly proportional to r to the power 4. Fine. Now in the next case, when you are increasing the radius by 2 times. Okay, so this is 2r and this is 2r, right? So on increasing the radius, force will vary as r to the power 4. Fine. So force will increase by 2 to the power 4 on increasing the radius to 2 times, right? So 2 to the power 4 is equal to what? It is 2 into 2, 4, 4 into 4, 16. So new force will be 16F, which is option 4. Question number 24. The length of simple pendulum is increased by 44%. What is the percentage increase in its period? So let's say initial time period is 2 pi under root L upon G. New time period T dash is 2 pi under root L dash upon G, where L dash is the new length. So it is L plus 44% of L, which is 1.44 L. So T dash will be 2 pi under root 1.44 L divided by G, which is equals to 1.2 times 2 pi under root L upon G. 2 pi under root L upon G is the old time period, so it is 1.2t. Right. Now, percentage change in the time period will be T dash minus T upon T into 100. T dash is 1.2t minus T upon T into 100. So, it will be equal to 20%, which is option 2. Question number 25. A rod PQ of mass M and length L is hinged at point P. The rod is kept horizontal by a massless string tied to point Q as shown in the figure. When string is cut, the initial angular acceleration of the rod is when you will cut the string. What will happen? This rod will rotate about this point P. Why? Because this mg will provide initial torque. है ना? Fine. So torque provided by mg will be mg into L by 2. This separation will be L by 2. Fine. And this torque is equals to I alpha. Now what is moment of inertia of this rod about this point? One of its end. It is ml square by 3. Right. So this is mg L by 2, which is equals to ml square by 3 into alpha. So it will be alpha will be 3g upon 2l. Correct answer is option 1. Question number 26. Question number 26. A particle of mass 2 kg moves in simple harmonic motion and its potential energy U varies with position x as shown in the figure. The time period of oscillation of the particle is. So basically the potential energy of the particle is maximum, and over here when x is equals to 0.4 meter and it is equals to 1. So maximum potential energy in this case will be half k a square, and that is equals to 1 joule, right? So half k a square will be 0.4 whole square, and this is 1 joule. So it is half k 0.4 into 0.4 is equals to 1. So k will be 2 upon 0.4 into 0.4, right? So this will be 50. 50 by 2, 50 by 4 is 25 by 2. So this is the value of k, right? Now time period is 2 pi under root m upon k. M is given as 2 kg. So it is 2 pi divided into under root 2 divided by 25 by 2, which is equals to 2 pi under root 4 by 25, and it will be 2 pi into 2 divided by 5, which is 4 pi divided by 5 seconds, which is option 4. Question number 27. A body of mass 0.01 kilogram executes simple harmonic motion about x is equals to 0. Under the influence of force as shown in figure, the period of SHM is. So force is varying like this. When the force is 8 Newton, it is minus 2. So F is equals to minus kx. So for this position, you can write 8 is equals to minus k, x is minus 2. So k will be 4 Newton per meter. Okay. Now time period will be 2 pi under root m upon k. So this is 2 pi, m is 0.01 divided by k is 4. Okay. So it will be 2 pi upon under root 1 upon 400, which is 20. So it will be pi by 10 second, which is approximately 0.31 second, option 4. Next is question number 28. A horizontal platform with an object placed on it is executing SHM in the vertical direction. So we have a platform something like this, and it is performing SHM in the vertical direction. The amplitude of oscillation is 4 into 10 power minus 3. Okay, what must be least period of this oscillation so that the object is not detached from the platform? So when the object will go up and when the platform is at its upper extreme position, what will happen? It will come down after attaining the extreme position. So in this case, there are chances of detaching this object from the platform. So at that particular position, this normal reaction mg, right? So force should be equal to normal reaction, and over here your force is what? Force is m omega square into a, and this should be equal to mg, right? So basically from this one you can write omega square is equals to g upon a, which is 10 upon 4 into 10 power minus 3, which is 10 power 4 divided by 4. So omega will be under root of 10 power 4 divided by 4, which is 10 power 2 divided by 2, and that is equals to 50, right? So this is omega, but we need to find the time period. So omega is 50, which is 2 pi by t. So time period will be 2 pi by 50, and that is pi upon 25 seconds, which is option 1. Question number 29. A particle executes linear simple harmonic motion with an amplitude of 3 centimeter. When the particle is at 2 centimeter from the mean position, the magnitude of its velocity is equal to that of its acceleration. Then its time period in seconds is. So basically, at any position x, magnitude of velocity is, it is given as v is equals to omega into a square minus x square, and in this case it is given as omega square x. Fine. So this will cancel this. So we have omega s under root of a square minus x square divided by x, which is equals to under root of 9 square, 3 square minus 2 square divided by 2. So this will be under root of 5 by 2, which is 2 pi by t. Omega is 2 pi by t. So time period will be 4 pi divided by root 5. So correct answer is option 3. Question number 30. The ratio of kinetic energy to the potential energy of a particle executing SHM at a distance equal to half of its amplitude is, the distance being measured from its equilibrium position is. So we need to find the ratio of its potential energy and kinetic energy at a distance half of its amplitude. So x will be a by 2. So u is half k x square. So it will be half k a by 2 whole square, which is half k a square by 4. Right. Now, total energy is half k a square, right? So, kinetic plus potential will be half k a square. So, kinetic will be half k a square minus potential, which is half k a square by 4. So, in this case, kinetic energy will be 1 by 2 into 3 by 4 k a square, right? So, ratio of kinetic to potential k upon u will be 1 by 2 into 3 by 4 ka square divided by 1 by 2 into ka square by 4. So this will cancel this, 4 will cancel 4, and ka square will cancel this ka square. So we have correct answer as 3:1, which is option 2. Question number 31. A particle executing simple harmonic motion covers a distance equal to half its amplitude in 1 second. So x is equals to a by 2 from its mean position is covered in 1 second. Then the time period of the simple harmonic motion is. So x is equals to a sine omega t. X is a by 2, which is a sine omega, and time is 1 second. So in this case, omega should be equal to sine omega should be equal to 1 by 2. And sine is 1 by 2 when omega is pi by 6, right? So omega is pi by 6, which is equals to 2 pi by t. So from this equation, you can find time period as 12 seconds. So correct answer is option 4, which is 12 seconds. Question number 32. A body is projected from ground with a velocity u vector is equals to 30 I cap plus 40 j cap meter per second. Then its range is, take g as 10 meter per second square. So basically ux is 30 meter per second. This is x component. This is y component. So this is 40 meter per second uy. Range is given as 2ux uy divided by g. So this is 2 into 30 into 40 divided by g, which is 10. So this is 240 meter, which is option 1. Question number 33. A thin ring of radius 0.5 meter is rolling without slipping on horizontal ground with angular velocity 5 radian per second. Then speed of topmost point on the ring is. So speed on the topmost point is v plus omega r. V is equals to omega r in this case. So it will be 2 omega r. So it is 2 into 5 into r is 0.5, which is equals to 5 meter per second. Right. So correct answer is option 4. Question number 34. A wheel of radius 10 centimeter can rotate freely about its center as shown in the figure. A string wrapped over its rim is pulled by a force of 5 Newton. It is observed that the torque reduces angular acceleration alpha is equals to 2 radian per second square in the wheel. What is the moment of inertia of the wheel? So, torque reduced by this 5 Newton will be F into R, which is 5 into 0.1, and this is equals to I into alpha. So, I will be 5 into 0.1 divided by alpha, which is 2. Right, so it is 0.5 divided by 2, which is 0.25 kilogram meter square. So, correct answer is option 1. Question number 35. One of the rectangular components of velocity of 50 km per hour is 40 km per hour. What is the other component? So we know that the magnitude of any vector in the form of rectangular component is rx square plus ry square. Okay. So in this case, it is given as 50, which is equals to, let's say rx is 40. So this is 40 square plus ry square. So it will be 2500 is equals to 1600 plus ry square, and ry square will be 2500 minus 1600, which is 900. So ry will be under root 900, which is 30 kilometer per hour. So another component is option 2, 30 kilometer per hour. Question number 36. The maximum acceleration of a particle executing SHM is alpha. So maximum acceleration is omega square a, which is alpha, and the maximum velocity is beta. Omega a is the maximum velocity, which is beta. The time period of SHM is given by the expression. So let's divide these two equations. A will cancel this A, 1 omega will cancel this 1 omega. So omega, which is equals to 2 pi by t, is equals to alpha upon beta. So basically time period is 2 pi beta upon alpha, which is option 4. Question number 37. If angular momentum is conserved, then linear momentum must be constant. Not necessarily true. Net external torque acting on the system must be 0. Yes, because tau is dl vector divided by dt. If angular momentum is constant, dl by dt will be 0 and net torque will be 0 on the system. So correct answer is option 2. Question number 38. A truck traveling due north at 20 meter per second turns west and travels with same speed. Okay, what is the change in velocity? So if you take this as x-axis, this is y-axis. So initial velocity is 20 j cap. Final velocity vector is minus 20 I cap. So change in velocity is v final vector minus v initial vector, which is minus 20 I cap minus 20 j cap. Right. So if you draw this vector like this is minus 20 I cap, this is minus 20 j cap. Right. So the resultant will pass through this diagonal According to parallelogram law of vector addition, this is 20, this is 20. So this angle is 45, this angle is 45, and this is your south direction, this is west. So the resultant will pass through southwest, and the magnitude will be under root of 20 minus 20 square plus minus 20 square, which is equals to 20 root 2. So net change in velocity is 20 root 2 meter per second along southwest direction, which is option 1. Question number 39. A particle has an initial velocity u vector as 3 I cap plus 4j cap and acceleration vector as 0.4 I cap plus 0.3 j cap. The speed after 10 seconds is. So v vector will be u vector plus a vector into t. So it is 3 I cap plus 4j cap plus a vector is 0.4 I cap plus 0.3 j cap into t, which is 10. So this is 3 I cap plus 4j cap plus 4 I cap plus 3j cap. So we have 7 I cap plus 7j cap, right? So magnitude of this will be, sorry, not this one, this is the vector form. Okay. So magnitude of this will be under root of 7 square plus 7 square, which is 7 root 2 units. So correct answer is option 4. Question number 40. The position of a particle moving in a xy plane at any time t is given as x is equals to 3t square minus 60 meter and y is equals to t square minus 2t meter. Select the correct statement about the moving particle from the following. So we need to find the velocity at t is equals to 0, 1 and acceleration at t is equals to 0, right? So if you differentiate x with respect to time, you will get velocity along x-axis, which is equal to differentiation of 3t square minus 60, which is 3 times 2t minus 6 times differentiation of t is 1. So this is 6t minus 6. At t is equals to 0, it is 0 minus 6, which is minus 6 meter per second. At t is equals to 1, if you put t is equals to 1, it is 6 into 1 minus 6, which is 0 meter per second. So along x-axis, the velocity will become 0 at t is equals to 1. Now let's find Vy. So Vy will be dy by dt, and it is differentiation of t square minus 2t, which is 2t minus 2. So again at t is equals to 0, velocity is 0 minus 2, which is minus 2 meter per second. And at t is equals to 1, it is 2 into 1 minus 2, which is 0 meter per second, right? So velocity in both the direction is becoming 0 at t is equals to 1, right? So the velocity of the particle is 0 at t is equals to 1 second. At t is equals to 0, it is non-zero. If you further differentiate this expression, you will get ax, which is 6, and ay, acceleration along y, which is 2. So at t is equals to 0, at t is equals to 1, 2, 3, 4, the acceleration of the particle will be constant along both the axes, 6 and 2 meter per second square respectively. So that is why correct option is option 3. Question number 41. The acceleration of a projectile relative to another projectile is. So we have two projectile, 1, and this is, let's say, another projectile 2. Fine. So both of this projectile will experience acceleration due to gravity. Gravitational force experience hoga, right? So acceleration of 1 is vertically downwards, that is equals to g. Acceleration of 2 is also vertically downwards, that is equals to g. So A1 is G, A2 is G, and along minus J cap, right? So acceleration of 1 with respect to T is A1 vector minus A2 vector, which is minus G J cap, minus of minus G J cap, which is minus G J cap plus G J cap, and that is equals to 0 vector, right? So relative acceleration is 0. Option 4 is correct. Question number 42. A man can swim with a speed of 4 km per hour in still water. So, velocity of man with respect to river is given as 4 km per hour. He crosses 1 kilometer wide river that flows steadily at 3 km per hour. If he makes his strokes normal to the river current, so he starts moving in this direction. how far down the river does he go when he reaches the other bank? So basically 4 km per hour will help this man to cross this river, but 3 km per hour will provide the drift. It should go here, but he is reaching here. So this is the drift produced by this 3 km per hour. So drift is 3 into time. Now what is the time taken to cross the river? It is width of the river divided by velocity in the direction of width, which is 4 km per hour. So 1 by 4 hour is the time taken to cross the river, which is equal to 3 into 1 by 4, and that is equals to drift. Okay, fine. This is the kilometer. So options are in meter. So let's multiply this thing with 1,000. So it will be 750 meter. So this is the drift produced by the current of the river, which is 750 meter. Question number 43. A person walks at a rate of 3 km per hour. So this is the velocity of person, 3 km per hour. Okay. Or you can write it as velocity of person vector as 3 I cap. Rain appears to him in vertical direction at the rate of 3 √3 km per hour. So velocity of rain with respect to men is 3 √3 km per hour. I am taking this direction as x and this direction as y. So in this case, velocity of rain with respect to men vector is 3 √3 j cap. Right? What is velocity of rain with respect to men? So it is VRM vector is equals to VR vector minus VM vector. VRM is 3 √3 j cap is equals to VR. I don't know what is VR, and V minus VM, which is 3 I cap. So using this relationship, you can find VR vector as 3 √3 j cap plus 3 I cap. So basically the actual velocity of the rain in x-axis is 3 and in y-axis is 3 √3. Fine. So this is the vector summation of this two, and this is angle theta. Fine. So the magnitude will be under root of 3 √3 square plus 3 square, which is equals to under root of 36, which is 6 km per hour. So magnitude is 6 km per hour. Okay, this is not possible. This is, and this is possible. Now let's find this angle theta with the vertical. So if this is 3 √3, this is also 3 because this is 3. Okay. So in this case, tan theta, which is perpendicular divided by base, is 3 upon 3 √3, which is 1 upon √3. And tan theta is 1 upon √3 when the angle is what? 30 degree. So in this case, the angle will be 30 degree to the vertical towards the person ka motion, right? So correct answer is option 3. Next is question number 44. A plane is flying horizontally at 98 meter per second and releases an object which reaches the ground in 10 seconds. So this is the ground level. When the object is released from the plane, from the moving object, the object will gain the velocity of the moving object. So object will get initial velocity as 98 meter per second in the horizontal direction. And there's only one acceleration that is acting on this object, and that is acceleration due to gravity in the downward direction like this. Okay. So there's no acceleration in x-axis, along x-axis. So motion of the particle along x-axis will be uniform, and motion of the particle along vertically downward direction will be what? Accelerated motion, right? So this particle will perform horizontal projectile, something like this, and it will fall here. We need to find the angle at which it will hit the ground. So this is the angle theta that we need to find. Okay. Since the motion is uniform along x-axis, final velocity along x-axis will be 98 meter per second. Final velocity along y-axis will be uy plus gt. Uy is 0. There is no initial velocity along y-axis, so it is 0, plus g is 9.8 into t is 10. So again Vy is 98 meter per second. So basically we have Vx as 98 meter per second Vy as 98 meter per second, and if you make a parallelogram something like this angle is theta that we need to find. So if this is 98, this is 98, this is also 98 meter per second. So using this triangle you can find tan theta as Vy upon Vx, and that is equals to 98 divided by 98, which is equals to 1, and tan theta is 1 when the angle is 45 degree, which is option 2. Question number 45. A particle is projected in xy plane with y-axis along the vertical. The point of projection is origin. The equation of the path is y is equals to root 3x minus g by 2x square, where y and x are in meter. Then the speed of projection is. So equation of the trajectory is given as y is equals to root 3x minus g by 2 into x square. And let's compare this equation of trajectory with this one. Y is equals to x tan theta minus g x square upon 2 u square cos square theta. Right. So in this case, tan theta will be root 3. If you compare this term with this term, tan theta will be root 3. So theta will be, tan theta is root 3 when the theta is 60 degree. Right. Now let's compare this term with this term. So we have g by 2 as equals to g by 2 u square cos square theta. So u square cos square theta will be 1. Right. So u square will be 1 upon cos square theta, and it is 1 upon cos square 60 degree, which is 1 upon 1 by 2 whole square, which is equals to 4. Right. So u square is 4. So u will be 2 meter per second. So the speed of projection is 2 meter per second, which is option 1. Question number 46. If u vector is ai cap plus bj cap plus ck cap, I, j, k are in east, north and vertical directions, the maximum height of the projectile is. So maximum height is basically given as u square sine square theta divided by g, but u is not given. Magnitude of u you can calculate, right? And sine theta is not given, right? So using this formula I'll have to do some manipulation. U sine theta is the velocity of the particle in vertical direction. So this is basically u vertical square divided by g. Now vertical direction velocity component is c. So u vertical will be c. So height will be c square upon, this is 2g, sorry, c square upon 2g, right? So vertical height will be c square upon 2g, which is option 3. Question number 47. Two cliffs of height 120 meter. This is, let's say, 120 meter high cliff, and another one is 100.4 meter, are separated by a horizontal distance of 16 meter. If a car has to reach from the first cliff to the second, the horizontal velocity of the car should be. Let's say horizontal velocity of the car is u, so it will perform this motion something like this, and its range will be 16 meter. So range is u into under root 2h by g. Okay. Height will be the difference in heights of these two cliffs, which is equals to 120 minus 100.4, and that is 19.6 meter. Okay, so this is u into under root 2 into 19.6 divided by 9.8, which is u into, this will be 2, and that is equals to 16. So u will be 8 meter per second, right? So correct answer is option 4, 8 meter per second. Question number 48. A ball is thrown with a velocity of u, making an angle theta with the horizontal. Its velocity vector normal to its initial vector after a time interval of. So, initial velocity vector of any projectile in projectile motion is given as u cos theta I cap plus u sin theta j cap, and velocity at any time t is given as u cos theta I cap plus u sin theta minus gt j cap. Now when these two vectors are perpendicular to each other, u dot v, the dot product will be 0. So dot product of u and v will be u cos theta into u cos theta, which is u cos theta whole square, plus u sin theta into u sin theta minus gt, and it should be 0. So this is u square cos square theta plus u square sin square theta minus u sin theta into gt, and it should be 0, right? You can take u square common, so it will become cos square theta plus sin square theta minus u sin theta into gt, and it will be 0. Sin square theta plus cos square theta will become 1, right? Identity. So we have u square minus u sin theta into gt is equals to 0. So t will be u square upon u sin theta into g. So it will be u upon g sin theta. So this is the time after which these two velocity vectors will be perpendicular to each other, which is option 3. Question number 49. A wheel of circumference c, that means 2 pi r is given as c, so r will be c upon 2 pi, is at rest on the ground. When the wheel rolls forward through half a revolution, then the displacement of the point of contact will be. So this is the wheel and it is revolving through half of the revolution. So it will be over here and the point of contact will be here. So total this linear distance will be pi r. This will be 2r equal to diameter, and the displacement will be this one. So this displacement x will be under root of 2r square plus pi r whole square, which is equals to under root of 4 r square plus pi square r square, right? So you can write r square as c square upon 4 pi square. So it will be 4 into c square upon 4 pi square plus pi square into c square upon 4 pi square. So 4 will cancel this 4, pi square will cancel this pi square. So we have total x as under root of c square upon pi square plus c square upon 4. You can take c square outside, common and outside, so it will become c. So x will be c times under root of 1 plus 1 upon pi square plus 1 by 4, which is option 1. Question number 50. Assume that the acceleration due to gravity on the surface of the moon is 0.2 times the acceleration due to gravity on the surface of the earth. If RE is the maximum range of projectile on the earth's surface, RE, which is maximum, which is u square upon GE, right? Maximum range is u square upon G, and that is equals to RE on the surface of the earth. What is the maximum range on the surface of the moon for the same velocity of projection? So for maximum range on the surface of the moon, it should be u square upon gm, right, which is equals to u square upon 0.2 re. Okay, 0.2 ge, sorry, gm is 0.2 ge, so it is 5 times u square upon re, but u square upon re is the maximum range on the surface of the earth, so rm will be 5 times re, which is equal to option 4. So that is it for today's session, guys. Thank you so much for watching this session, and do subscribe to our channel Infinity Learn by Sri Chaitanya. And thank you so much, guys. Take care, everyone. Bye.